When a legacy enterprise tries to adapt to modern operational demands, the digital equivalent of metal begins grinding to a halt. The physical friction of misaligned systems simply cannot process the modern workload. Today's industrial and corporate sectors face pressure from multiple converging angles. Supply chain costs are rising, there is a critical shortage of highly skilled technical labor, and regulatory mandates are tightening across the globe. The standard approach to managing this pressure relies on localized, fragmented software. Project managers track costs in isolated spreadsheets, while engineers design systems in entirely different, disconnected programs. This siloed data architecture requires manual transfer from one department to the next, creating severe operational blind spots. By the time raw data is compiled and placed in front of an executive, the information is obsolete, delaying critical decisions. Add in the strict new requirements for environmental, social, and governance compliance, alongside net zero emissions tracking. Calculating precise, real-time carbon footprints requires a level of integration that standard legacy ERPs cannot handle. Scaling an enterprise under these conditions is no longer a localized data problem, it is a systemic failure. Surviving this environment requires an entirely new architectural foundation. Nexergy AI Systems developed a specific thesis for this bottleneck. Survival requires shifting away from suites of disconnected applications in favor of a unified system of systems architecture. The execution is the NexergyHub. It acts as the centralized integration layer, pulling scattered data points into a single, structured environment. NexergyHub functions as a central nervous system, acting as a communicative bridge connecting highly specialized business platforms across entirely different industrial sectors. By routing all data through this centralized hub, complex corporate goals, like executing a massive sustainability transition or hitting aggressive growth targets, become measurable, automated, daily operational realities. To see how this architecture dictates physical reality, we look first at the specific vertical platforms driving infrastructure development, starting with construction AI. The construction lifecycle is notoriously difficult to track. This platform digitizes that chaos by automating the generation of bills of quantities and immediately plotting those material requirements on interactive Gantt charts. By linking these schedules directly to a real-time profit and loss tracking module, contractors gain the ability to dynamically control cost overruns before the capital is actually spent. The second vertical branch shifts focus to the renewable energy sector, specifically engineered for the engineering, procurement, and construction workflows within the Solar AI platform. Here, the platform takes raw lead data and automatically calculates the exact solar capacity and system design required for a specific site. This chart demonstrates the direct conversion of those technical specs into financial reality. The module takes raw megawatt capacity and instantly calculates specific investment metrics, plotting the exact return on investment, internal rate of return, and payback period. But an energy project must prove its environmental value as well. The solar platform integrates carbon analytics to measure and verify the exact carbon reduction of each proposed installation. By digitizing these highly complex vertical workflows, physical infrastructure companies replace manual guesswork with exact, data-backed project execution. Once the infrastructure is built and solar panels are live, the challenge shifts inward to the daily operational execution inside manufacturing facilities. This is where the industrial AI platform deploys. It acts as the bridge linking the hard realities of the factory floor with strict corporate sustainability mandates. On the floor, the system tracks the required traditional core metrics. It monitors production KPIs, quality management data, and schedules predictive maintenance. This split-screen dashboard highlights the core operational tension. On the left, we track traditional production output. On the right, the platform simultaneously calculates energy management usage and the resulting carbon footprint in real time. The ESG Executive Dashboard takes both the heavy industrial production data and the environmental compliance data, aggregating them into a single coherent view. Embedded AI analytics continuously scan this aggregated data stream. They detect operational anomalies, like sudden spikes in power consumption, and alert management long before a compliance breach occurs. True operational efficiency requires a unified system where maximizing physical production and minimizing carbon output are managed on the exact same pane of glass. Advanced AI dashboards and optimized green infrastructure have zero practical value if a company lacks the skilled workforce required to operate them. Scaling all these new technologies demands the rapid acquisition of entirely new human skills across the global labor pool. The Job AI platform serves as the ecosystem's human capital engine. It is built as a holistic workforce development tool to solve the technical labor shortage. The system deploys AI to execute precise job matching while simultaneously running automated skill gap assessments on incoming applicants. When the platform identifies a skill gap, it directs the applicant to integrated upskill and reskill training courses. This rapidly develops the specific green tech competencies that employers require, closing the hiring loop entirely within the ecosystem. Yet, an optimized workforce and massive factories only account for a fraction of the economy. Small and medium enterprises carry the bulk of economic activity, and they carry the highest risk of being left behind in the digital transition. The fifth and final pillar of the architecture is the SME and BCG platform. This platform democratizes enterprise-level planning for smaller operators. It provides an AI-assisted business model canvas and automates complex financial projections that SMEs normally lack the resources to generate. It also features a specific BCG, Bio, Circular, Green, assessment tool. This module prepares smaller businesses for strict ESG readiness audits, actively positioning them to secure green business grants and favorable lending. Technology drives macroeconomic shifts only when it empowers the human workforce and provides a scalable, accessible entry point for small businesses. A fragmented network of legacy spreadsheets creates friction, delays, and costly blind spots. The fully built Nexergy architecture eliminates that friction entirely. The architecture functions as a single, continuous nervous system, allowing data to move instantly across all 5 industrial sectors simultaneously. Trace a single data lifecycle through this architecture. A corporate requirement for a new ESG-compliant factory is initiated, and the data flows immediately into the construction platform to generate precise timelines. That same project profile then pulls design resources from the solar platform for renewable energy, and sources technical talent from the Job AI platform to execute the build. Once operational, its daily emissions and production output continuously feed back into the industrial platform, generating automated executive reporting in absolute real time. The end result is accelerated, data-backed decision-making. Companies can achieve exact control over their project lifecycles while maintaining seamless tracking of all environmental, social, and governance metrics. Treating artificial intelligence as simply an isolated novelty is now a measurable strategic failure within the modern global enterprise landscape. Future market competitiveness belongs strictly to organizations that embed AI as the very foundation of their daily infrastructure. Nexergy AI Systems has successfully engineered this infrastructure. They have successfully built an environment where corporate strategy, physical operations, human capital development, and environmental sustainability are inextricably linked. It is a central architecture designed to empower immediate business growth while securing the transition to a sustainable green economy.